Hi guys, welcome back. Well, I've been machining the resin that had gone off rapidly in that plastic cup that I mentioned in one of my previous videos, and I've decided I'm going to make a Robert the Robot from Fireball XL5. So I've been slitting these down, and 1, 2, 3, 4. I've got 6 at the moment, and that was the first one that I did. But that's probably twice the width it needs to be, so I'm going to mount that in the lathe again and split that into 2. So I'll get 2 out of that one piece. And I've still got this chunk left, so out of that 1 cupful of resin I'll probably get the 2 elbows out of that. So for the knees, if I mix the same quantity, that should give me the 2 knees. So that's the situation with those. Now, a while ago, probably 5-6 months ago, I had a trip to Derrick in Halifax, and he's got a unit there, the basement of an old mill, and it's just an Aladdin's cave of engineering equipment. It's just unbelievable. I'm hoping at some stage to have a trip up there, and I'll do a video of it and just show you what's available there. It's just unbelievable. Anyway, I picked a large selection of lathe tools up, all different shapes and sizes. That was probably one of the biggest ones, but there are some that they're all HSS. There's no carbide tip ones, and I was looking at these to use on the shaper. Now, some of them, the shanks, the right width to slot into the slot, but the bigger ones are obviously too wide to go in. Now, some time ago, this was probably about that length to begin with, and I chopped a section off and made a tool holder for some of the smaller cutting tools that I've got. So that's been cut in half. And I was looking at this the other day, and I thought that would make an excellent shear tool. There's a There's a 30-degree shear angle already machined into the cutting tip. You see that one there? The only problem is the main body is too wide to go into the slot on the tool holder. Now, not sure what width those are. Yeah, that's 16mm. So my plan is, guys, if I machine this section down and I measure the 16mm from this edge, overall it's 26, so it needs 10mm off this side. Now, I don't know if it's hardened material or not. I'm just going to get a file and just see if the file touches it. Yeah, well, the file will take some off, so I think I'm going to machine the 10mm off on the milling machine. I've got a large face mill with ceramic tips in it, which I have used before, and it makes short work of removing 10mm off that. Well, I've been doing a bit of maintenance on the shaper. I've managed to find a handle for cranking the table up and down. In the past I've just been using a large adjustable spanner, but that'll make life a lot easier. I've given everything a good clean down, and I've taken the cover off. I've not changed. I've had this machine 5-6 years now, and it was the original oil in the sump. I've never cleaned it out, so I've taken the cover off, cleaned the old oil out, and treated it to some new oil. So while the cover's off, guys, I thought I'd show you the inner workings of the shaper. Well, I'm going to have to do this handheld, guys, just bear with me. This is the front cover that's been taken off. I've got the motor running at the moment. Now, I believe this to be quite a late model machine. There is a name plate down at the bottom, which I can't remember if there's a date on it or not. I'll try and have a look before I finish this, but that's the inner workings with it. As I say, I believe this is quite a late model machine. There is an oil pump inside. I think you can make it out there. Now that only works when the ram is moving, but that lubricates all the gears. I think you can see there in the corner. But it also sends oil up to the ways that the ram moves on. I think the earlier models have oil in points on top of the ways, but this automatically lubricates the ways, so I think that's an improvement on the original designs. We'll just switch it on and see if we can see the oil pump moving. You can see the oil dripping down from the waves back down into the sump. When it's been running for 2 or 3 minutes, you can actually see the oil build up on top of the wares. And on the other side, there's a sight glass to show you that the oil is actually reaching the wares at the top. There's 3 settings on it, A, B and C, which control the amount of flow of the oil that comes to the wares. I'm not quite sure why you'd need a control on it, but there are 3. When you stop the ram, that stops the pump as well. You've just got the wheels fitted round from the motor. That's the sight glass, guys, that show you the level of oil, and next to it is a control of the flow of the oil. There's 3 settings, A, B and C, and it's on A at the moment, and the oil is pretty low down. So if you turn it, you can see the oil flow rising on the glass. That's on C now, so that's the highest setting. far more convenient than having the oiling points on the top. Right, let's get this over to the milling machine and see if we can take that 10mm off. Well, these are the speed controls for the vertical mill. The top two, they have the one on the left has 2 positions, the one on the right has 3, and those control the revolution of the spindle. I tend not to use those because I've got the machine running on a frequency drive, so I've been controlling the speed with the drive. The bottom 2 are for the speed for the table. Again, there's 3 settings on this side and 3 on this, and there's a chart on that tells you inches per minute, the direction of the table. This button with inch on, I believe, is for advancing the gears. If you want to change the speed, sometimes the cog alignment doesn't allow for an easy change, so pressing that inch button just moves them on slightly, so you then can change the speed. If you want to rotate the head, there's 4 pinch bolts, 2 on this side, 2 on the opposite side. You undo those, and then there's a tapered pin which locks it in the 0 degrees position. I don't know if you can make that out. They're marked in degrees. There's a 0, and 30, 40, goes up to 50 plus or minus, and there's a locking lever here for the quill that locks the quill in position, and then there's some oiling points for the quill and the transfer gears from horizontal to vertical. I've been watching Kimber's Alex channel, and he's been fitting a condia head to his South Bend milling machine. I think when he first got it up and running, he realised that the taper on the spindle nose was out, and he'd been trying to get over it anyway. He decided in the end to buy another head to fit onto it, but I don't think there's any comparison between the nodding head and a fixed one like this. If you just look at the mass of that, the thing's enormous. Diameter of the quill itself's 7 inches, and then once these pinch bolts are screwed down and you've got the tapered pin in position, there's just no movement at all on that. So no, I just don't know why they went on to the nodding head design from this. I think this dates back to about 1952. One possible reason is just look at the size of the castings. Everything's cast iron on it. The main upright is one piece, and then you've got the head design, which is on this flange, which mates up to this flange. So possibly a lot cheaper making the nodding head design than having one of these cast. But for rigidity, the thing's a beast. Well, this is the facemill I'm going to use for taking the 10mm off. It's 5 inch diameter. It's a 16mm drawbar, and this has ceramic tips. 1, 2, 3, 4, 5, 6, 8 tips on it, and I have used this in the past. I've also got another one that takes circular cutters, but that's a 5/8 drawbar on that, which means tilting the head and swapping the drawbar over. So I'm going to use this mainly because it's a 16mm.